I want us to make a conclusion that we shall use it throughout.
This a raised to 6 plus 6a raised to 5b plus 15a raised to 4b squared plus 20a raised to 3b raised to 3 plus 15 raised to 4
15a
squared b raised to 4 plus 6a b raised to 5 plus b raised to 6.
Good. Good. Okay, the last one. A plus b brackets raised to 7. The last one. Somebody to read it for us. Then we start following through. Unaiona lakini? Okay. This is a raised to 7 plus 7, a raised to 6b plus 21, a raised to 5b squared plus 35, a raised to 4b raised to 3 plus 35, a cubed b raised to 4 plus 21, a squared b raised to 5 plus 7a b raised to 6, and finally plus b raised to 7. I want us to look at what we call behavior of terms. Behavior of terms. Behavior of terms. Are you paying attention?
Yes.
Look at the behavior of these terms. That when it is raised to 2, the first term, A, this is the first term, A, is raised to 2. The second term, mwisho, is raised to 2. That when it is raised to 3, the first term is raised to 3. The last term, B, the second term is raised to 3. Look at them. That when it is raised to 4, the first term is raised to 4, and the last term is B raised to 4. Even ukiendelea sana, even chini huku, A plus B raised to 7, the first term is raised to 7, and the coefficient 1, all these ones are coefficient 1, and then the last term is B raised to 7. This 7, this 6, this 5, this 4, this 3, this 2, and this 1. These are called external powers. External powers. Powers that are covering the brackets. So the last terms are raised to external powers. The last terms are raised to external powers. The first terms are raised to external powers. And the coefficient of the first and the last terms is always 1. Ukiona hii Pascal's triangle yetu hii. This one we have made ourselves. We are the ones who have made this, although it is in our mathematical tables. When you come across a question that deals with expansion, binomial coefficient expansions, you simply take your mathematical table, open a page for binomial coefficients, and then you read the line that you want. If they want raised to 5, you just go to that. The coefficients will be 1, 5, 10, 10, 5, 1. They can't ask you to do this. This will be done at a higher level. Raised to 10, for instance. Your curriculum, your syllabus does not require that we do higher powers than even raised to 6. I've only put here so that you know how they are done. You know how they are done. Otherwise, if they ask us to expand, for instance, raised to 10, they may only require the first 5 terms, the first 3 terms, or the first 4 terms. They will not ask us to expand the whole of it up to the end in an exam, a KCSE exam situation. What happens is they will only require a part of it. So we have determined that the first and last terms will be bearing the external powers. Let us now go step by step. Look at This A is called the first term. This B is called the second term. So A, B, first, second term throughout. Let us see how they are behaving. That when it is raised to 2, the first term is raised to the external power, but in the second term, the first term is raised to the second term, second power, the external power, I think reduced by 1. Then this is also reduced by 1. It's also raised to 1, and then like that. Let us see what happens with the third, the raised to 3. The second term, first term is raised to external power, 3. But in the second term, this is raised to 2. In the third term, this is raised to 1. In the last term, even the A is not there. And in the first term, you realize B is also not there. When we are dealing with indices, a power 0. When we raise any number to 0, that number will just be 1. And the 1 multiplied by any number will just be that number. So this one means that at this point, when we have no B, B is raised to 0. And at that point also, when we have no A, A is raised to 0. So here, in the first term, B is raised to 0. Likewise, in the last term, A is raised to 0. Let us go to raised to 4, tuone. A raised to 4 plus 4, A in the first term is raised to external power has reduced by 1. And then in the third term, the first term is raised to 2, meaning it has reduced again. And in the second term, in the first term, A raised to 4, B should be raised to 0. So that in the second term, A is raised to 3, B is raised to 1. In the third term, A is raised to 2, B is raised to 2. In the fourth term, A is raised to 1, B is raised to 3, and finally A is raised to 0 in the last one, and then B is raised to 4. If we follow through, raised to 5 will be A raised to 5, B here is raised to 0. That is why it is not even appearing there. Then second term, A is raised to 4, B is raised to 1. A is raised to 3, B is raised to 2. A is raised to 2, B is raised to 3. A is raised to 1, B is raised to 4. A is raised to 0, B is raised to 5. If we continue that way, you realize that at all, in all the terms, the sum of the indices are powers. Index is 1. Many are called indices. So in all cases, the sums of the powers are the same as the external power here. Look at these terms. A raised to 4 and B here is raised to 0. So that 0 plus 4 is 4, which is external power. Here, second term, A is raised to 3, B is raised to 1. 3 plus 1 is 4, which is here. Third term, A raised to 2, B raised to 2. The sum is 4. Fourth term, A raised to 1, B raised to 3. The sum is 4. Fifth term, A raised to 0, B raised to 4. The sum is 4. We can even pick raised to 6. A raised to 6, B raised to 0. The sum is 6, external power. B, second term, A is raised to 5, B is raised to 1. Sum 6. Third term, A is raised to 4, B is raised to 2. Sum 6. Fourth term, A is raised to 3, B is raised to 3. Sum 6. Fifth term, A is raised to 2, B is raised to 4, sum 6. Like that, until you finish. And even in the lower one, hii ya mwisho, A raised to 7 external power. That means B is raised to 0. The sum is 7 external power. Second term, A is raised to 6, B is raised to 1. Sum 7 external power. Third term, A raised to 5, B raised to 2. Sum is 7 external power. Then A raised to 4, B 3, sum 7, like that. So the behavior of terms is such that the powers of the terms should always be the same as the external power. That is what you should keep in our minds. That the Pascal's triangle has already been made for us. It is in our mathematical tables. And we have also made ours. So that you know that this person, Blaise Pascal, did not just wake up one morning and had this. He also made a triangle the way we have made ours here. This is the Pascal's triangle. It is used to determining binomial coefficients for various expansion terms. So this is what we have. And the behavior of terms is such that at all levels, all the terms, the powers, the sum of the indices, the sum of the powers should be the same as the external power. I don't know whether there is any question. Students, any question?
Yes.
Yes, Ulisa.
Where at A plus B raised to power 4.
4, yes.
You say that the power, the sum of the powers should add to the
external power, yes.
Yes. Then here at 6, A raised to power 2, B raised to power 2.
Where?
See, now the powers are 2 and 2.
Raised to 2, here.
No, at 4 there.
Here.
A raised to power 4 plus 4 raised to
A raised to 3.
Plus there at 6.
Yes.
6 A squared. Yes, there. See now 2 plus 3 is 6.
2 plus 2 is external power. 4. You want, what am I hearing? You want the powers, 2 plus 2. I explained so well that the sum of the indices, these are powers. The sum of the indices should always be equivalent to the external power. So that if it were raised to say 10, the powers of the terms should always be 10, 10, 10 at all levels. So for A plus B brackets raised to 4, this is the same as A raised to 4. In this term here, B is raised to 0. Why am I saying that? In our normal mathematics, any number raised to 0 is 1. And 1 times any number is just that number. So this means B raised to 0 is hiding somewhere. B is also here but hiding. It's because it is raised to 0. Then when we come here, it is raised to 3, raised to 1, raised to 2, raised to 2, raised to 1, raised to 3, raised to 0, raised to 4. So that the sum of those powers will always be raised to, will always be the external power, which is 4. Is there any other question? Or are you okay? Have I explained well?
Yes.
Yeah. Now any other question before we proceed? Any other question? Hakuna? Wacha tusonge mbele. We are now going to start expanding, and as we expand, you keep this table should be with you. Where you feel it, perhaps you cannot keep it so much, utasahau, and you know in mathematics we don't cram. We use the formula or formulas so many times so that we are used to them, we know them. But you don't cram and they say I'm cramming the formula pi A of A volume for a cylinder is pi r squared h. Use it until it is part of you. So this one, this table, for instance, mimi nimetumia mpaka najua up to, I can say a few things, and there is some level of mathematics that you will do at a higher level when you join universities. There is a topic that used to be in book 4 KCSE, but then it was removed because it proved to be slightly complicated for your young heads. It is called permutations and combinations. Now with the combinations, I don't need your mathematical tables to say the Pascal's coefficients or binomial coefficients. I will just be using combinations to get the coefficients at any one time, the way I want. I will be calculating. So for you, use your mathematical tables. We have also made our table in your exercise books now. Use those ones. For now, I want us to start expanding now real terms on the ground. Let us begin with this. We have been dealing with the positive. Can we expand a negative one? A minus B. Let us expand A minus B brackets raised to 4. Nani anaweza kuniambia, who can tell us the binomial coefficients for this one? A minus B brackets raised to 4. Who can tell us the binomial coefficients? Is 1, 4, 6, 4, then 1. Those are the coefficients. Then behavior of terms now. That will be A raised to 4, B raised to 0, plus 4A raised to 3B raised to 1, plus 6A squared B squared, plus 4A B raised to 3, plus 1A raised to 0 B raised to 4. So that is what we have. Behavior coefficients and behavior of terms. Then now we take out the answer. 1 times A raised to 4 times B raised to 0. Any number raised to 0 is 1. 1 times 1 is 1. Times A raised to 4 is A raised to 4. Plus 4A cubed B. That one has no complication, so we write it here. 4A cubed B. Plus, wait. This is negative. This is negative here. That is negative. This is negative squared. This is negative B cubed. Then that is negative. So when we take out, this one will become negative. This will be negative. This one will be positive. A squared B squared. And then this will be negative 4A B cubed. And finally plus B raised to 4. Your mics must be having a problem. You are not, are you getting me?
Yes.
Now, are you okay with this answer? 4A minus B brackets raised to 4 gives us A raised to 4 minus 4A cubed B plus 6A squared B squared minus 4A B cubed plus B raised to 4. Is that alright?
Yes.
Haya. Wacha tufanye ingine. Let us do another one.